So, by and large, like most gasoline injection gasoline engines, right, or SI engines, right, or petrol engines use a MPFI system. An alternative which has come up, okay, is what is called as gasoline direct injection, okay, what is called as GDI. Okay. So, what is this gasoline direct injection? Okay. Traditionally, we started with carburetor, then people moved to MPFI engines. Now, gasoline direct injection is also popular. So, what is gasoline direct injection when we compared with port injection? I am going in a sequence, okay, so that we compare one with the other, right. So, here in a gasoline direct injection system, the operating pressures increase. Okay. Now, they are of the order of 10 power 2 bars, okay, hundreds of bars. Okay. So, what happens in a gasoline injection system, or sorry, gasoline direct injection system? So, if we compare it with port injection, we can immediately observe even from the term gasoline direct injection that now the fuel is going to be directly sprayed into the engine cylinder, right. So, previously we saw that the fuel was sprayed somewhere here, right, upstream of the intake valve. Now, the injector is placed such that it will spray gasoline directly into the cylinder, right. So, that is the what to say concept behind this gasoline direct injection. So, fuel is injected directly into the cylinder when the suction stroke is in progress, okay, and the piston is, let us say, near BDC. Okay. So, it is getting closer to BDC. Okay. So, when the suction stroke is progressing. Why higher injection pressures? Because please note that now the volume over which the fuel has to penetrate is more. See, previously in carburetor or port injection, it needs to be introduced in a small volume, right. In port injection, we introduce in the intake pipe, right, or the intake path, right. So, the fuel will mix with air and go into the cylinder. But here now we are injecting directly into the cylinder. So, the fuel jet should be sprayed like a mist, and it should also penetrate into the cylinder, right, is it not? Because otherwise, like the fuel will, there will be a rich locally rich pockets of fuel air mixture which will not result in good combustion, right. So, higher pressures are required to enable, of course, compared to port injection. See, we are comparing to the previous cases. Since the fuel spray must penetrate the cylinder against the in-cylinder pressure, because previously when we were introducing the port, there was already air flowing through the port, right, that essentially took away the fuel, right, to us in a certain sense. Here we need to spray against the in-cylinder pressure and also essentially go directly into the cylinder, right. So, obviously the advantages are multiple: comparatively better atomization and vaporization, right, when we compare to a port injection, right, and we will see that we remove wall wetting in the intake path or pipe, right, because we are spraying directly into the cylinder, and we can have a shorter injection duration to deliver the same mass of fuel, because with higher injection pressures the mass flow rate will be more. The mass flow rate is more, in order to deliver the same mass you can have a shorter injection time, right. So, those are advantages. Of course, what is the main limitation? Cost and complexity increase, right. So, if you want these benefits. So, this is GDI, okay, gasoline direct injection, okay. So, the next one that we are going to look at is the following: diesel direct injection. So, anyway in diesel engines the combustion of the fuel happens due to self ignition, and as we have already seen, in a diesel engine the injection of fuel happens towards the end of the compression stroke. So, the diesel fuel has to be sprayed against high pressure in the cylinder, and not only that, it has very little time to atomize, vaporize, and the formation of a homogeneous mixture. So, due to all these reasons the operating pressures are very high, okay. So, this can be of the order of thousands of bars, okay, in a diesel direct injection engine, okay. So, how does this work? A simple schematic is as follows. So, we can observe that once again the fuel is directly injected into the engine, okay, using this injector, okay. So, you can see that the injector directly will spray the fuel at very high pressures. Please note that although the volume of the combustion chamber or the cylinder is small, because the diesel is injected towards the end of compression, the pressure is high. So, the time available for the fuel to vaporize, atomize and vaporize and form a combustible homogeneous mixture is also small when compared with SI engines. So, all these factors should be kept in mind when we design a injection system for a diesel engine, right. So, that is why the pressures are pretty high, okay. So, we can observe that fuel is injected slightly before TDC, as we have already discussed in the previous class when we discussed the combustion process in CI engines, and we have better vaporization, better atomization and vaporization, of course, okay, can use less volatile fuels such as diesel, right. Since the temperatures are also going to be high, right, diesel engines are going to be higher compression ratio engines, okay. So, we can use less volatile fluids like diesel, okay, which can essentially combust, okay, which can vaporize and still combust due to the high pressures and temperatures that exist in the cylinder. So, we can use less volatile fuels such as diesel due to higher cylinder pressures. Okay. So, essentially we have operating pressures in the range of 10 power 3 bars, and this ensures like very good vaporization, right, and even the rate of delivery of the fuel is also pretty high. Okay. So, those are the attributes of a direct diesel direct injection system. Obviously, the cost and complexity are very high. So, what people do, what the system that is popular today in diesel engines is what is called as a common rail system. So, what happens in a common rail system is that the diesel fuel is pressurized to a high pressure in what is called as a common rail. Okay. Okay. So, and then from this rail you go to multiple cylinders. Let us say you have 4 cylinders to cylinder 1, 2, 3 and 4, right. So, the fuel is taken to the 4 cylinders, so that the pressures are pretty uniform, right, when we inject at very high pressures, and we avoid any major pressure fluctuations, right, if we use a small channel, right, directly to pump the diesel fuel. So, this common rail acts like a high pressure local reservoir, a small capacity, so that you take from that common rail and spray it directly into the cylinder. Okay. So, that is what is called as a common rail system, okay, used for injecting diesel. So, broadly these are the 4 fuel introduction systems, okay, the simple carburetor, port injection, gasoline direct injection and diesel direct injection. Okay. So, these are the 4 broad categories of injection systems. As we have seen, the pressure ranges at which these injection systems operate kept on increasing as we went from one to other. Okay. There are both pros and cons associated with each. Okay. So, in order to get an insight on how this air fuel ratio can be regulated, let us go and analyze the simple carburetor, because as I mentioned at the beginning, one objective of this course is also to use concepts that we have learnt in basic undergraduate engineering courses, right, that we take in the first year or second year, right, to analyze various automotive systems. So, let us go and look at the simple carburetor and let us do an analysis of that. Okay. So, let us now consider what is called as a simple carburetor, a basic carburetor which is used to get the appropriate fuel air mixture. So, let me first introduce to you the various components of this device, and then we would do the analysis. So, this is a simple schematic of this carburetor. So, we can see that air enters the carburetor, okay, and this is what is called as a choke valve. We will come to the choke valve later on. Okay. The throttle valve is downstream in the carburetor, and we can see that we have a venturi. So, we can observe that the venturi is a reduction in the cross section of the carburetor, and we have what is called as the throat of the venturi, right, the place where the cross sectional area is the least. Now, air is coming into the carburetor, and we have this it passes through the venturi. As it passes through the venturi, because the cross section drops, the pressure drops and the speed increases, okay, and the speed pressure drop becomes the highest at the throat section, where the speed will be the highest. Okay. Now, at the throat section we can see that there is what is called as a fuel dispersing nozzle. Okay. So, this nozzle tip is placed at the throat, okay, what is called as a fuel dispersing nozzle or a fuel discharge nozzle. Okay. So, that is placed at the throttle, and this pipe is connected to the float chamber, which is the local what to say source of fuel for the carburetor. So, we see that we have a float which is connected to the fuel inlet, and that maintains a common constant level of fuel always in the carburetor. And the carburetor is also vented to the atmosphere, okay, so that the pressure at the top surface of the fuel in the carburetor is close to atmospheric pressure. Okay. So, we can see that the throttle valve is downstream and the fuel discharge nozzle is placed at point 2, okay, in the cross section BB prime. Okay. The point 3 corresponds to the top surface of the fuel. One can observe that there is a difference in the elevation between point 2 and point 3. You can see that the top surface of the fuel in the carburetor is placed vertically below the fuel discharge nozzle. Why? That is because typically the pressure at point 2 is always lower than atmospheric, okay, most of the time. If they were at the same level, what will happen? Although the elevation is the same, the pressure is lower at point 2, so the fuel may bleed even when it is not necessary. That is, the fuel may get into the carburetor and get wasted, and it may leak even when it is not required. So, the level of the fuel in the float chamber is slightly below the tip of the fuel discharge nozzle to ensure that fuel is taken from the float chamber only when there is a sufficient flow of air in the carburetor and there is a sufficient pressure drop. Okay. This elevation is quantified by this parameter h. So, the small h is used to quantify the what to say elevation difference, okay, between these two points. Okay. So, these are the main components of a fuel a simple carburetor, and this difference in pressure is what is called as carburetor depression. So, what is carburetor depression? It is the difference in the pressure between the top surface of the float chamber and the venturi throat. Okay, that is what is called as carburetor depression. Of course, this pressure difference keeps on varying, right, as we operate the carburetor, right. So, it depends on the pressure at point 2, right. So, that is going to be what is called as carburetor depression, and to avoid overflow of the fuel through the fuel discharge nozzle, okay, the level of fuel in the float chamber is maintained slightly lower than the tip of the fuel discharge nozzle. Okay, the fuel dispersing nozzle is called by some as fuel discharge nozzle. Okay, so they are used interchangeably. Okay, so these are some important what to say concepts. Okay, so once again, please note that the air is drawn from the atmosphere through the air intake system and it enters the venturi. As it goes through the venturi, there is a pressure drop and the speed of air increases, and due to the pressure drop at the venturi throat, fuel is essentially sucked from the float chamber depending on the amount of pressure drop, and the flowing air takes the fuel from the fuel discharge nozzle, atomizes this and takes it downstream, okay, past the throttle valve to the intake pipe. Okay. So, that is what happens in this simple carburetor. So, the main components are this float chamber, okay, which contains all these subcomponents, the venturi section, the fuel discharge nozzle, the throttle valve and the choke valve. The throttle valve is what is under the control of the driver, okay. So, that can be opened and closed by the driver. We will I want to say look at how this carburetor functions in more detail in the next class by looking at the throttle valve and the choke valve in closer detail, and we will also use simple concepts from thermodynamics and fluid mechanics to analyze this carburetor. Okay. So, I will stop here for this class and we will continue in the next class. Thank you.